this process. So now we are going to go into Chapter 2. And we're recording this just so that I can have the notes. I'm really bad at facilitating and taking notes at the same time. So this is an opportunity to reduce that burden a little bit on me and to have kind of a record of how people are thinking about this plan or changes that need to be made to it. And so we're, for the next little bit, going to do our Chapter 2, which is about connecting climate science and first foods. And so this is our dreaded climate science chapter. Every plan has to have one, right? And so this is a chance for us to kind of look at the science around why carbon is important and why carbon dioxide emissions from fossil fuels are wreaking havoc on some of our systems. And so we're going to go until 12:20 will be our next break. And so we're going to try and keep on time to that, but also people have been sharing really amazing information. And so don't feel like we need to really stick to the schedule. We will make time for, our various breaks and things, no matter what happens. So thank you again all for being here. So I'm just going to go into it. And again, if you want to say something, I can usually catch that raise hand function, but it might always just be easiest to unmute yourself and just start talking or say, hey, stop talking, I want to say something, because I kind of babble on a little bit. And this is about you. This is about your opportunity to talk about the plan. So, all right, let's get into it. So the climate science, I love this photo. Kate Ely took this photo. Kate, I thank you for making it available to me for use in this plan. I think it's a really lovely image that conveys the importance of snow and kind of the importance of cold winter for the lovely ecosystems that we have and the first foods that depend on that snowpack and that seasonality that has existed since time immemorial. So I thought it was a really good photo to start off this discussion with. So I think it's important to know a little bit about the climate science, and that was actually a directive that I did get from the Board of Trustees. Corin Sams recommended that I not shy away from the science in this document. And so this is really this opportunity to look at that kind of science-heavy part of all of this issue. But I tried to use lots of pictures, so there is at least that attempt to make it a little bit more accessible. And so I start with kind of just an overview of what greenhouse gases are and why they're important. And so I know on all of these I need to do citation. So that is something that I have not been very good about in this draft plan and need to be better about in the actual plan, is including references to everything. So thank you for being patient with me in my process. But these two diagrams here are just to kind of show that carbon dioxide is a problem, and it is truly us. It is the human influence that is driving this. And so this first diagram, it starts at 2011 down here is this lightest color. And then 2017 is when this document ends kind of its projections. And so you can see every year in between there is really the carbon has increased in the atmosphere. And we see this natural seasonality of carbon dioxide availability. And so that is definitely an element, is the carbon cycling throughout the Earth, but we can very visually see that it is increasing year after year, and it's not just the Earth's natural function doing this. And figure 2.2 is kind of an attempt to address the idea of, oh, climate changes naturally. Climate does change naturally. This is very true, and tribes have been adapting to natural changes in climate since time immemorial. We have a lot of cultural, archaeological, and geological information that shows that tribes have weathered changes in climate over thousands of years. The difference between this is the speed of that change and kind of the thing that's driving it. And so this chart shows The green, the light green here is what we would expect to see in global temperatures if it was just natural changes in climate. And then the blue is what we would expect to see if it was natural changes in climate as well as human contributions. And so we see that without human contribution, this green line here, we would actually be going into a period of global cooling at this time. And that this black line observation shows that we are in fact not going into that period of cooling. And so it more closely follows this natural and human factors, which is pretty definitive evidence that human contribution is really what is driving global climate change. I really like figure 2.3, especially for a lot of mixed audiences, different perspectives on the issue, as well as different ages and kind of different knowledge bases. What this is a color spectrum of the global temperature per year based on where it falls in that range. So what they've done is they've taken the coldest year from that 1890 to 2017 period, and they've given it the darkest color blue. And then they've taken the hottest global temperature during that same time period, and they've given it that darkest red color. And all of the temperatures and years in between fall on this gradient that they've kind of assigned different shades of blue, red, or neutral colors to based on where they fall in that that color scheme. And so these are now arranged chronologically here on this graph. And so we can see that there is definitely a non-randomized warming pattern. If warming was not occurring, these colors would be randomized. We would see a lot more red down here in this end of the spectrum. We would see darker blues up here at this end of the spectrum. But we in fact see this non-randomized warming, which is again just more evidence that what we think is happening is actually happening. Any discussion about climate change would be remiss without information about the greenhouse effect. The greenhouse effect is a normal, actually very helpful phenomenon for our planet. It makes life possible on our beautiful blue marble. But the problem comes when we start adding carbon to this cycle that wasn't there to begin with. And so we cause all of these additional complications in the greenhouse effect. And so this diagram I really like because it kind of shows what we hope to see, which is that this very small arrow of remitted heat and a large arrow of escaping out to space gets thrown out of balance with this much, much larger arrow here being kept within the Earth's atmosphere and a much smaller arrow escaping out into space. And so this is just kind of a conceptualization of how climate change changes the greenhouse effect that is a very natural phenomenon. I kind of start here in this chapter at like a global scale and then move closer to what is relevant to the tribe. And so here at a global level, this is a real broad generalization of the effects that climate change brings. And so here is, kind of a historic measure of seasonality at a real, again, general level. So we have some extreme cold events, we have some extreme hot events, and lots of stuff in between. And then this red line here shows our climate shifted future and kind of the overlap that we start to see. And so we will see less extreme cold, but that doesn't mean zero extreme cold. As we've seen in recent years with the polar vortexes that have drifted down across a lot of the United States and Canada. We hear a lot of uninformed people saying, oh, it can't be climate change, it can't be global warming because it's really cold outside. That in fact is actually an effect of climate change, is the loss of those tight circles in the Arctic continent that keep that cold air up there. And so the extreme cold that we see is still evidence of climate change. But we will also see an increase in extremely hot weather. And this is an impact that plays out in different ways across the world, but is still something that we share with the rest of the globe. And again, if you want to say anything about anything that you're seeing, the opportunity is now. Just unmute yourself and jump right in. And I will pause right here at kind of the end of the global discussion to take a sip of water and also give opportunity for anyone to share if they'd like. All right, drilling in some more regional impacts. So the next part of this chapter goes into generalized Pacific Northwest impacts. And so generally, we've kind of talked a little bit about really the main things that we'll see here in the Pacific Northwest. We are not a coastal tribe, and so sea level rise is not really a concern for us. But what we will see instead is the incidences of heavy precipitation that result in flooding, and then the wildfire and smoke that really go along with it. And kind of in between, as a function of both of those two things, is more severe summer drought. Although this is really an impact that as we get into the plan, we see that we can buffer for a little bit more than some of these other two effects. But these three, flooding, drought, and wildfire, are really the predominant impacts that we will see here from climate change in the Pacific Northwest. And so, as with everything, it starts with the choosh. We start with water, and from all things, water flows. And so when you change the water, you change quite a bit about the way that the world can relate to each other, itself, and to us. And so we see this chart is from International Panel on Climate Change graph for the Pacific Northwest. They have a very specific kind of examination of this area. And so we see this kind of generalized watershed here, with the black line representing what has historically existed hydrologically. And so we can see, you know, historically, there's been kind of a two-peak hydrologic system where we have, you know, mostly rain-fed peaks here in the middle of winter, but then we have this really pronounced spring snow melt that feeds into rivers to give water to the river into the summertime. And we see with these colored lines here, so the blue is a projection for 2020, very recent. The yellow is for 2040s, so kind of mid-century, and then the red line is the 2080s, or kind of late century. And so we see that as our winters warm, we lose this really pronounced spring melt peak right here, and it kind of gets muddled further into the winter the longer we go. And so we see this kind of homogenized peak here in the winter time as opposed to in the springtime. And that has some pretty dramatic effects for the beings that rely on water, which is all beings. Let's see. Sam says another Pacific Northwest impact is the increase in heat-related injuries, such as heat stroke and heat exhaustion. Absolutely. And this is something that we spend a lot of time examining in depth in the human health and happiness chapter. And so that actually, the complications from increased heat are tremendous. There are about 27 different pathways that extreme heat impacts people who have pre-existing health conditions that can cause complications. And over, you know, a number of years of exposure, that actually really takes a toll. And so absolutely, there's a little bit of a graphic here later on that talks a little bit about extreme heat.
Okay, perfect.
Yeah, but if you wanted to say something, please.
Nope, I just hadn't had a time to look through it, so I'm sure you captured it.
Perfect. No, I'm really appreciating your guys' contributions. It's interesting to design in a vacuum and then have, you know, commentary from others. So I really am appreciating the review of this. So the next part of this, I kind of go a little bit more in depth into these three impacts. And so obviously winter precipitation. This is kind of a repeat of what we just saw in a regional scale, except that this is very hyper local. This was a chart developed by our Office of Information Technology GIS program. Scott O'Daniel and Bethy Rogers-Pacheco actually authored this modeling study that looks at our Umatilla River and effects into the future. And so they came up with this conceptualization of the Umatilla River Basin and how it will change over time. And so in the blue, we see is kind of historical record of the river and its behavior. And then the red is an amalgamation of different forecasts that they used, and they have a lot of specific information about the types and amounts of forecasts that they compiled together to create this projection. But we can see again that moving of the cycle, that loss of kind of those duality peaks to be a more homogenized kind of winter winter peak flow, but we also see an increasing magnitude as well as an increasing variability. So these bars are called error bars, and they represent kind of the variability that exists within this data point. And that's really important because it's easy to say, oh, well, this thing is going to happen because the model says that it will. However, one of the things that we do see as a climate change impact is the variability of seasonality. And so this error bar shows that, yes, we expect to see more flooding, but on a year-to-year basis, we might see less flooding or more flooding. We can't really know. And so I think the last couple of years has been a really good example of that. Not only did we have that dramatic 500-year flood event last year, and I know a lot of people this year were really worried about flooding, but we had a rather mild precipitation season this past winter. And so we see that climate change is causing more flooding. However, that might look different year after year. And we have to be prepared for that amount of difference. Again, in case people are saying, well, this didn't happen exactly the way that you predicted. And so therefore climate change is not happening. We expect an amount of variability. And Kate, I don't know if you'd like to talk a little bit about the need for variability in river seasons and hydrology, but you've noted in the past that variability is a very natural thing. And so it does play into kind of the role of the water cycle and the first foods that depend on it.
Yes, I will comment on that flow variability. And I'm trying to reconcile the two graphs that are presented here, the figure 2.7 and figure 2.6. And so we'll discuss a little bit more about the shift versus the range in discharge.
Okay.
Okay.
Yeah, that sounds really good. I also should mention that I'm making my rounds to different departments and committees and commissions to discuss the details of this at the same time that I'm doing public outreach. So I've got a number of side conversations going on as well. Thank you for having patience with me. So summer drought. As I kind of talked about before, I see summer drought as a function of the shifting hydrology. It's not necessarily in and of itself its own impact, but it definitely comes from the way that we manage water. And to try and conceptualize this idea for people, I've pulled out these two graphs from different sources. And so this is just kind of atmospheric, it's just science information. It's just earth science information about the way that precipitation becomes river flow, because I think that this is an important part of the conversation that we might not always have a real connected understanding of. And so it describes the idea of rain can fall directly on a river channel and become flow, but it can also fall onto the landscape and flow over lands, which we call runoff, which takes a lot of soil and contaminants away with it into the river, but it can also infiltrate into interflow, which is it percolates into soil moisture in shallow water aquifers and feeds back into that, that water supply and that base flow in the summertime. And so this is really just information of how our precipitation becomes river flow. And then on the right here, this is another IPCC International Panel on Climate Change graphic for the Pacific Northwest chapter, where it looks at reduced summer flow. So the idea of as water falls, or as precipitation falls more as rain rather than as snow, we're going to see a higher likelihood of this overland flow, because snow melts slowly and really easily becomes interflow, but rain really easily becomes overland flow. And so as we see more incidences of rain, we will see less availability of water in the summertime because of that change in the way that the water interacts with the landscape. And so on this diagram, it's a pretty homogenized, regionalized diagram, but we can see, kind of in our area, we have, this category, 20 to 30% reduction in this area. And so it's important to, again, remember that the way that the water changes has effects not only in the wintertime with the flooding, but also in the summertime with that reduction in base flow. And I'm going to pause here to see if there's any contribution to this discussion. All right, so the last risk, but not definitely not the least scary risk, is the wildfire and the smoke that it brings. And so we have seen over the last several years that it is not just wildfires that are close to us that are going to impact us. It's also really those regional fires. So fires burning in BC and Montana and California all filter their smoke into our airshed and really can sit on us for quite a while, even though the fires are not in our local area. And so being prepared for not only close fires, but also those long smoke inundation events is a huge component of being climate prepared. And so this is another graphic from that IPCC Pacific Northwest chapter, where it talks about kind of that insect relationship with fire. And Althea did a really good job of talking about the bark beetles, how they've been a problem since the 80s and continuing now into the future. And they have a relationship with fire because they weaken trees as insects infest into trees that are improperly managed. They weaken the tree and they create higher potential for it to die. And so a dead tree, obviously baking in the hot sun that we have, becomes a huge fire risk. And so the more insects that are prevalent on the landscape and infesting those trees creates a higher risk for wildfire here in our area. And so we see, you know, kind of this regional production of insect prevalence, and then the way that that will play out kind of on the landscape here into the future for fire risk. So we see, you know, here in our area, we're kind of a mix of this, you know, 100 to 200%. Then also here, basically kind of in the Blue Mountain system, 600 to 700% projected impact burn. So that is a tremendous increase in the amount of fire that we can expect to see here locally, as well as at a larger scale. So I'm going to pause to see if anybody wants to say anything further about insects and their fire and the relationship there.
Colleen, on some of your graphics, like this one, I would really like to see, I don't know if you're able to maybe break it up a little bit more, and then maybe have like an example and show like a species from here and what that beetle looks like, just because I think that when our tribal members are looking at this, it will help them connect a little bit more and know kind of what to look for as informants. Just to see some more images maybe from here, and maybe that's something, you know, as we go, I might have, you know, we might have some images to go with some of the graphs too, just so some of our elders and other people, you know, they'll kind of like engage and pull them in a little bit more by saying something that reflects to some of the graphs that we have and how that looks in relationship to the land or to them. I think that really kind of pull in a little bit more.
Absolutely. I love that idea. And I'm sure it wouldn't be too difficult to find a photo of one of those beetles that exists. I know that our forestry staff and you also, yeah, photos.
Yeah. And even just showing like an area of maybe the lake where they had to go in. You know, they have a couple of those projects that had to go in and thin, and what those stands look like too. Just kind of, I think that would really give like more of an impact when you're looking at this is what we see, because they'll be like, oh, I see that when I go in this area. So it helps them understand what they're looking for as that change.
That's perfect. Yeah. And I know that our forestry guys do have those photos because they were shared during our webinar. And so they have those really great side-by-side, like pre-treatment and post-treatment photos that I think would do exactly what you're describing. That's a wonderful suggestion. Thank you, Lennox. I'm gonna keep going. So here I have Sam, this is for you. Here's our extreme heat. But we also, these are kind of subcategory impacts. A lot, again, everything is derived from this idea that the water is changing. And so then it has all of these cascading effects. And so I wanted to just kind of pull out some of these visualizations of what those impacts look like. This is again from that IPCC report for the Northwest, or for, I think, just the national level. And so we see this kind of 12% increase in very heavy precipitation event. And heavy precipitation event is categorized as several, let's see, it's in here, 1 inch or more of rain or snow in 24 hours. And so a 12% increase, that number will kind of come back in some of those discussions in the water chapter as we're looking at trying to get numbers on some of these projections. Extreme heat is deadly for a lot of people, for most people, in fact. And so keeping an eye on extreme heat events here in our area is really important. And the idea of cooling, be it active cooling through air conditioning or passive cooling through things like shade or carefully designed structures, can really help reduce that heat effect. And so here is a graphic that was developed by the Climate Central. Oops. And it shows at a national scale where those extreme heat events are expected. And so we really do see kind of the Southwest to bear the brunt of this type of impact, but we here will see increases of 90-degree heat. And so that is what extreme heat is categorized as, is 90 degrees Fahrenheit or above. And so here we know that we get hot. I think in our climate vulnerability assessment, they did a projection for that. And they said that by the end of the century, we will probably see a month and a half of above 90-degree temperatures, which is astronomical and very hard to even kind of conceive of these days, except if you're standing outside in that temperature. And so keeping an eye on that is definitely part of this adaptation plan. There is a more recent estimate of the temperature, the extreme heat temperatures in a 2020 report done by Dalton and the Oregon Land Conservation, Land Development. I don't know. It'll come up later in the document, but we do have estimates of those projections. And then the last thing that I wanted to kind of highlight here miscellaneously is the tick pressure. So mosquitoes and ticks are two of the most virulent disease-carrying insect vectors. And I know that even just thinking about it, my skin is crawling a little bit about thinking about, coming in from outdoor adventures and finding a tick on me. And so we do see actually warming years favoring multiple iterations of these predatory insects, not just for our forests, but for our bodies and for animal bodies as well. And so there isn't necessarily a lot of projection for this for our area. There's a lot of projection in kind of the Southwest and the Southeast, but that is kind of a gap of information that is still relevant for us, is what is the risk of not only the ticks themselves, but disease-carrying ticks. I'll pause here for a moment before we go on.
The only other thing I was gonna say was insects and different things is the increase in algae blooms. They predict is going to be severe.
Yes, absolutely. And so we have algal bloom information in the first foods section, as well as in the human health section, the harmful algal blooms, HABs. Absolutely. And that was one of the things that I heard early on was feedback for this was up at Indian Lake and at Anthony Lake. Actually, a lot of people described this summer muck that would come onto the water, that blue-green cyanoalgae, blue-green algae. And how difficult that was, not only to make it to fish, was more of the commentary that, you drag in your line and it's covered in gunk. But then also those can be toxic. Not all blue-green algae are toxic, but a percentage of them are. And so it kind of just takes the wrong bloom to kick off to have a water source that is harmful to humans and animals. So that's a really good thing to call out. I see something in my chat, maybe. Oh yes, you just said that. Thank you. Okay, so in 2015, the thing that kind of kicked off, at least the documenting process of the climate change efforts, was a climate change vulnerability assessment that was conducted over 6 months. Was the meeting time for a focus group that was designed to put together these key items of concern. And then they had a one-day event up at Wild Horse Resort and Casino to get community feedback on this this document. And what they did was they worked with a contractor to look at downscaled climate modeling data for our area. And so I'm not going to go into the specifics of what is involved with the downscaling climate model. It's a lot of computer and analytics information. There's a little bit of it in here if you wanted to know more, but our climate vulnerability assessment does a really good job of going into that. And I will include that link here as part of this document. But they pulled out a handful of relevant conclusions for us, and these are mapped here in this little graphic that I put together with that information. And so we see kind of these generic time focuses for these, you know, a 5 to 12 Fahrenheit degree increase by the end of the century. Summer temperatures increasing 2 to 10 degrees Fahrenheit, winter temperatures increasing 1 to 8% Fahrenheit. This category is really important to me. This days over 90 degrees is exactly what we just talked about, those extreme heats. And so we see it doubling by mid-century to a month, and then tripling to almost, you know, a month and a half by the end of the century. And so again, if you go outside on a day over 90 degrees, you know exactly what that feels like. And to imagine that for a month and a half is what future generations will be facing. As part of that vulnerability assessment that was conducted, they also developed this vulnerability matrix of the key items of concern that were pulled out. And so you can see across the top is sensitivity. And so that basically just means how sensitive are species to these climate adaptation and these climate changes. So an example of a really sensitive species would be the freshwater mussels are extremely climate sensitive. They need the water temperatures to be at certain temperatures at certain times to be able to sync up with the host fish that they have a life cycle with. And so we can see up here, it says Chinook salmon is also another very sensitive species. And then on this axis, we have adaptive capacity. And so what that means kind of in a nutshell is how well are these species able to change their habitat or change their life cycle to in relation to what is happening to them. And so for a species that is really highly adaptive, we could see things like elk. So elk obviously are very mobile, they move around, they migrate in response to vegetation availability and temperature. One that is a really low adaptive capacity we see here also is salmon. You know, there's very narrow waterways that salmon spawn in, that salmon really succeed in. And so there is really a limited amount of moving around that they can really do. And so we see, you know, in this exercise that obviously salmon are a really high priority. They're both not able to adapt very easily in our framework and are very sensitive. But we also have a lot of these other concerns here. These say water short-term, vector-borne disease, things like heat waves, increasing crime. And again, if you're really interested in the mechanism and the methodology of this paper, I would recommend finding that vulnerability assessment, and I'm happy to get it to you. But it was a really interesting exercise in a snapshot of what the tribe cares about in terms of climate change. When it was addressed at kind of these really vague climate change threats, this is how people kind of responded. And so when I was doing kind of lessons learned from this, I was talking with people who were involved in this process, and it was stated that they felt that the kind of Western perspective of prioritizing things over another or trying to split out some of these impacts wasn't necessarily their favorite way of going about doing it. And it was also interesting because these sensitivity and adaptive capacities were set by the people who are involved with this. So you were handed kind of a sheet where you're asked, what is the adaptive capacity of couch? Like, how well do you think couch could be able to move in response to some of these climate changes? And so these were really broad answers, because I think my favorite answer to this was, oh, couch can adapt really well if we change everything about our land management system. So that is a very complicated answer to try and quantify. And so the idea of kind of these rankings are interesting and really depend on the thinking of the person submitting these answers. But it's really a wonderful document to draw on, especially as kind of a first glimpse into what this means in the future going forward. And I'm going to pause here to see if there are any thoughts or comments on the reflection of the vulnerability assessment.
Yeah, Colleen?
Mhm.
Though I haven't read this section completely, the graph, reading the elements inside the figure 2.15, it's kind of alarming in a way. If the green, there needs to be a color code and some explanation of the elements here, but I'm assuming green is not much concern, red is highest concern. Is that correct?
I do believe that that's the way it was structured. Yes. So that red, of course, yeah, that both sensitive and lack adaptive capacity, whereas green is less sensitive and more able to adapt.
Yeah. So there's water is not so a key item of concern. I kind of find that a little disheartening if I was to read that and think, really? Is there perhaps an explanation, as we've learned since the development of this document, that there are more items of concern and they're elevated to a higher position? Do you do that?
Yes, Kate. So I know that you and I have had conversations about the fact that water is rated so low in this.
Yeah.
That was very surprising to me when I read it. What I think has happened in this particular document is that a lot of the impacts to water were rolled into impacts to salmon. That idea of increasing water temperature and things. And so it was my attempt in the Climate Adaptation Plan, in response exactly to this critique, was to pull out water very, very explicitly. So I have an entire subchapter dedicated to surface water as well as ground.
Oh, that's chapter 3, and we're getting to that. So okay, so that it doesn't just leave this vulnerability assessment alone. You expand on it later.
Absolutely.
Right? Okay, good. Thank you. That's all.
Thank you. So the last little part of this chapter is just kind of going through some of those larger scale issues. So again, I said that sea level rise is not an explicit impact for CTUIR, being not directly coastal tribe. However, a lot of the traditional use area is over on the coast. And so there is concern about it. And so we don't spend a lot of time on it, but I did want to just kind of talk briefly about the science of sea level rise, because it's happening at two different stages. One, we are seeing a melting of land ice, which is contributing to physically more water in the ocean. But then we're also seeing this phenomenon of thermal expansion of water, where water molecules at a certain temperature, this close together, and at a higher temperature, they're farther apart because they expand as a fluid element does. And so sea level rise is resulting from both of those impacts coming together. And then again, ocean acidification is something that we care about because our salmon go to the ocean. This is something that CTUIR is, I think, interested in becoming more involved with, are ocean issues, because our salmon, while we might do our very best to rear them here, they do go to the ocean. And we hope that they come back. And so what is happening in the ocean is definitely a part of our land management and our first foods issues out here too, especially ocean acidification that's resulting in kind of a disruption of ability of small life forms to put on biomass. And these small life forms are the basis of the food chain for our salmonoid species. And so we do really care about that issue because it impacts our salmon in their whole life cycle. And so this last little bit talks about unknowns and feedback. So I don't know if you are a news reader very religiously. I can't not read the news. It's a pathos that I have. And so there's constantly some news story about something that we need to be paying attention to that feeds into the climate crisis in a way that we might not have anticipated. And so this little section tries to capture some of those things that are unknowns to keep an eye on. So we talk about the idea of the albedo of the Earth, the reflectivity of the Earth. And so as polar ice melts, we lose more of that very reflective material and it becomes more absorptive material. And so this adds to the rate of warming in a way that we don't really know yet. We also have pockets of methane in places in our world that can be unearthed as a result of this warming process. And methane is an incredibly potent greenhouse gas with 84 times the heating potential of carbon dioxide. And so the idea of those methane deposits escaping into the atmosphere could cause cataclysmic warming in a very short amount of time. But again, we don't quite know what that mechanism is going to be. Another one, the idea of tipping points was one that has been kind of broached in different circles. There might be places where we cannot come back from, places that we surpass that we are not able to recover from. And so knowing where those are and knowing kind of how those might play in would be important, but again, very difficult to know. And then the last thing that came up really recently that I just wanted to mention because it's bananas to me is this idea of the Earth axis has shifted as a result mostly of melting glaciers and pumping of groundwater onto the surface. And so our Earth axis is also slightly different, which will impact our climate crisis in a way that we don't really know, but also might impact our ability to navigate or, satellite information being conveyed. And so there are a lot of unknowns that have ties into this discussion. So I wanted to just note them. And I'll pause here for anybody that knows any other kind of terrifying information that we should include in this.
Well, another feedback is the increase in evaporation, evapotranspiration, sublimation in the atmospheric, removal of water due to increased heat.
Absolutely. That is a good one to know, especially, when we talk about vegetation management, our forests, the stocking density is a really important thing for making sure that water is reaching the surface of the earth and not just sublimating off of the tops of the trees, as you've mentioned. And so, yes, absolutely, that's important. I will make an addition to that, possibly in the land changes section. Thank you, Kate. And so we have a break at 12:20, and so I want to try and stay close to the time, but also it's okay if we don't. Just to conclude this chapter is, again, the idea of we are all connected, and the salmon is a really good image of this connection, a really good symbol of connection, because again, it is reared in our inland streams and migrates out to the ocean, which is really international jurisdiction, and then comes home. And so the tribe is engaged with the state and federal partners, and more international engagement could potentially be part of this for climate adaptation needs, because we are all in this together. And a number of people have noted that international fishing policy is definitely at play here when we talk about the return of the salmon. This is something that I don't really touch on in the plan, but I do kind of mention. There are a number of documents that go into fish policy a little bit more specifically. I should probably cite those in here. So did anyone have any thoughts on kind of the chapter as a whole or implications for governing regionally before we take a break? Okay, well, I think that that was a really good cover of what is arguably the most boring chapter in here. And thank you again for being with me, especially into our lunchtime. And so we're going to take another 10-minute break, and we're going to come back at 12:30 to get into the meat of the plan, Chapter 3, as Kate said, the real climate impacts specifically and what we can do about them. And so we'll cover the first little bit here today after our 10-minute break. So get some water, stretch your legs. I'll see you again at 12:30. Thank you, guys.